So in this video, it includes the required topics for us to advance to CCNA2. So mostly these topics are not taught to us last semester, but luckily through this video we will be able to learn it. So this video is also divided to 3 parts. The first part is some recaps of terms and topics like PDUs, iOS, TCP and IP, address schemes. So for the part of this video, it includes building a network. So designing our own network, configure a bunch of configurations, and then for the part 3, simply simulating it. So in this video, we will be discussing these topics: the TCP IP model, the OSI model, PDU, iOS, ARP, and address schemes. So on the last video, we already discussed this, but for the sake of this video, we will be having a quick recap on these terms and topics. So first, the TCP IP. So it describes how protocols enable computers to communicate over the network. So in the TCP IP model, we have 4 layers. We have first the application, starting from the top. Next is the transport. Next is the internet. Next is the network access. So in this layer, we have different protocols. So in this application, we have the HTTP, DNS. The transport layer, we have the TCP. The internet, we have IP. And then the network access, we have also Ethernet. So the TCP IP model can also compare to OSI model. So the OSI model provides overview on how computer systems communicate with each other. So in the OSI model, we have 7 layers. First is the application, starting from the top. Then presentation. Then session. Next is the transport. Next is the network. Next, data link, and then the physical. So in the application is basically the closest to the end user. So any software applications like Firefox, Chrome. Okay, for the presentation, in this layer, this is where the OS lies. Okay, so in this layer, it converts our language to the language of the computer, because every time we type in the computer our email, so the computer doesn't understand it. So in this layer, it converts our language into the computer language, the language that it can understand. So the language is the ASCII, what we call ASCII. So the session is basically the conversation. So it manages the conversation, maintains, establishes the conversation between the 2 end devices. So the transport layer ensures the packets are delivered reliably. Okay, in this layer, it also ensures the proper order of the packets. Okay. So in the network layer, it provides or determines the fastest route possible. And then for the data link, this is where the links are located, and it also checks for errors. Check for errors of the packets. Okay, so it is the communicator between the top layers and the physical layer. And then the physical layer is the layer wherein the wires are located. The wires, cable wires, fiber optics, also the wireless cables. Next is the PDUs, which stands for protocol data units. So protocol data units are just a description of different data transferred from each layer. So we have 5 different protocol data units to be discussed. First is the data. Next is the segment, then packet, frame, and then bits. So data is just the data from application layer. So data from software application. So data from software application. Next is the segment. It's just the encapsulated form of data. So it includes the TCP header and the data. So TCP header contains the source and destination ports. Mainly contains. So packet is the encapsulated form of segment. So it contains the source and destination IP address. Next is the frame, and it includes the source and destination MAC address. So this topic, I already discussed this on the last video. So this is just a quick recap. And then for the bits, all these frames, data on this frame are converted into binary. So binary, like 1, 0. Then these bits are now transmitted through network media such as cables, wire cables, fiber optics, and also can be on wireless. Next is the iOS. So every device needs an operating system or OS. For example, so for the PC and laptops, we have Windows, Mac, or Linux. And for the phones, we have Android and Mac. Is that we call Mac or iPhone OS, iOS. And then we also have for the switches or the network devices, we have switches or routers. We have Cisco iOS. So in accessing the Cisco iOS, we are accessing this through command line interface or the CLI for some configurations. So there are three common ways to access the Cisco iOS. So 3 most common to access the Cisco iOS. So first is the console port. Second is the through SSH. Next is the Telnet. So console port is an outbound port, meaning they are outside of the network. So console port is usually used in configuring the router. Okay. So the SSH and Telnet, they are both inbound. They are both inbound, and the main difference between these two is the SSH is for secure, meaning that when we are transmitting data over the network, SSH is in the secured or encrypted, while the Telnet is plain text. So the next topic is the ARP, which stands for Address Resolution Protocol. So ARP determines the destination MAC address. So device referred to an ARP table or ARP cache to determine the destination MAC address of the destination device. For example, this host or the host 1 needs to transmit data to host 3. So host 1 needs the MAC address of this device. It will refer to its ARP cache or ARP table based on the IP address of the host 3. But sometimes devices doesn't have an entry, so which means for example, I need to send this host host 1, I need to send information to this address. So 192.168.1.7. So this device, but I only have the IP address. I don't know the MAC address of the device that has that IP. So what happens is this host sends an ARP request to all this device. So ARP request is a broadcast address to determine the destination MAC address. So this device doesn't know the MAC address. If the destination address is on the same network, so this device will refer to the ARP table to search its IP address. But if the destination address is on different network, this device will refer to the ARP table and search for the IP address of the router or the default gateway. So after receiving the ARP request, the only device that has an IP address associated with the target address on the ARP request will respond with the ARP reply. So ARP reply contains the sender's IP address and sender's MAC address. We also have a thing called ARP spoofing. So some hosts pretends to be the default gateway. For example, so I need the MAC address of the default gateway. So it sends the broadcast address of ARP request, and this host C pretends to be the default gateway. So it responds with an ARP reply, and then this host here receives the ARP reply and then updates its ARP table, and then obviously it will communicate with this host, with this attacker. So for the last topic is the address schemes. So address schemes is all about efficient use of IP addressing. So in this photo, traditional subnetting creates equal size subnets. So using traditional subnetting, it creates equal host addresses in each subnet. For example, we have here 8 subnets with 30 hosts each. So if all networks requires like this, or requires with the same number of addresses in each subnet, this addressing will be efficient. But in real life, it's not the case. So in addressing schemes, it's mainly involves the VLSM. The VLSM, or stands for variable subnet mask. So I will be discussing this on the part 2. But for the address schemes, we should first planning IP address assignment. So this means that we need to examine the network. We need to examine on how many addresses are required in each subnet. We should also determine the main sections of the network and how we'll be able to segment it. In this part of the video, we'll be setting up our network and then apply these requirements to the network. So we will having IP addressing with proper VLSM distribution. We will also add IPv6 configuration for some device. We will also configure router and switch. We also need wireless LAN to our network. So with DHCP, DNS, email, and FTP. So we also will create LAN to the network, and then configure Telnet and SSH. So I already set up my network, my topology. So as you can see, we have here one server, then 2 switches, 2 PCs, then I also we have also the 2 routers, then access point, then 4 devices. So I use access point to create wireless LAN. So as you can see, we have here a laptop that is not connected to the access point because I haven't connected it to the Wi-Fi. So here I supplied this. So I haven't done any configurations other than setting up the IP address for devices, except for these two devices here, because I plan to supply this with the DHCP. So as you can see, we haven't done any IP addresses. And then, so in this video, so we'll be distributing this. I distributed this using the VLSM. So VLSM stands for Variable Length Subnet Mask. So variable subnet mask is all about efficient use of IP addressing. So in my topology, we have 4 networks. So in our first network, we have here with the interface of gigabit 0/0 and then the server. So I supplied this address, those two. So I use a subnet mask of /30. So it's 255.255.255.252. So I use this subnet notation because I only need 2 addresses. Okay. Then we have here the second network here. So these 2 PCs are connected to the gigabit Ethernet 0/1 of the router. So we have the IP address of 192.168.11.1. So the first network, we have the network address of 168.0/30. And then for the second network, we have the network address of this one. So we have a subnet mask of 255.255.255.248. So this is the subnet mask in this /29. So this PC, I haven't configured the IP address of this PC. So we will supply the IP address of this PC by DHCP later on the video. Next is we have the third network. It is located here. So we have this address 209.165.200.225 and this serial port. Then this IP address on the other serial port. And then for the fourth network here, so the fourth network, it is designed as wireless. So I use the access point to create wireless LAN. So this interface, we have supplied the network address. So this network has the network address of 0/29. So I supply this interface, the gigabit interface, with the IP address of 10.1.1.1 and then .2, .3, .4, and then the second laptop, we don't have IP address. We will supply this with DHCP. And first, after ending this part of the video, we will connecting this to the Wi-Fi, the access point. Is that PC wireless? Okay. Okay. We need turn off, then remove that module, and we need a module that is wireless. Okay, let's forward. And then for the PC wireless, we will connect to the access point. Fresh Wi-Fi. We will connect. Then we will enter the web key, WEP key 4567890. Then we will connect this. Now it is connected. So in this part of the video, we will be adding IPv6 address. So for some device, so specifically, we will add some IPv6 address on the server, and then in this PC. Then after that, we'll be ping this one if they receive the messages. So first, we need to enable the router to send IPv6 packets. So go to the CLI. Then so enable, then config key, then hostname R1. Then we need to enable the router with this unicast routing. So this line here enables the router to send IPv6 packets. So we need to type in, and then next thing we do is configure the interfaces of the router. So we will supply this with the IPv6 address. So I already prepared some IPv6 address. So this address would be on the interface gigabit 0/0 of the router. Then this address would be on the gigabit 0/1, and then this is for the server, and this is for the PC. So type in to the CLI interface G0/0. So goes to the interface of 0/0, and then we need to set the IPv6 address. Then we should copy this one. And then we will configure the link local address. So IPv6 address. Then we use this link local, paste. Then I'm sorry, IPv6 address. Then the link local. So link local means that we are staying on the same network. Okay, then we need to configure the 0/1. Then also put this IP address, IPv6 address. Then same as the link local address. Okay, so we already configured the router. Next is the server. We just add the IPv6 here. Server, and for the link local address /64, /64, and then gateway. Okay. Then for the PC, we also prepared some IPv6 address. 64, and for the link, the IPv6 gateway. Then now we'll be able to ping each other. So first we will ping the server. So type in ping, then the IPv6 of the right router. It's pinging, So we are receiving reply from the server. Then we also ping the PC here, so the command prompt of the server. Also have a reply, and that is configuration of IPv6 address. So in this video we will be configuring the switch and the router. So as you will notice later on, so the commands for switch and router is the same. So for the router and switch, we will configure its device name, secure the user exec mode. So this secure remote Telnet and SSH access, we will do it later in the video. We will also secure the privilege exec mode for router and switch, and we also secure all the passwords. And then we also provide legal notification for switch and router. So this means that we will configure the banner MOTD, or the banner message of the day. So the banner message of the day is whenever someone tries to access the switch or router, so a message will display. So it serves as a warning for the attackers. So in the last, we will save the configuration. So first we will configure the switch, type enable, and then first thing we will show the running configuration. So as you can see, we haven't done any configuration before. So the host name is set on the default. The interfaces, the first thing we do is to configure the device name. So go to the global configuration and then type in host name and then the host name that you wanted. Then as you can see, the default switch name changed just to S1. Next is we need to secure the user exec mode. To secure the user exec mode, type in line console 0 and then password. Type in the password Cisco, then exit. Then the secure remote Telnet SSH, we will do this later on the video. Then next is the secure privilege exec mode. So enable secret class. So I forgot to log in on the line console 0. So 0. Okay, 0. Password Cisco. Then log in. Next is to secure all passwords. So let's show the running configuration. So as you can see on the password for the line console 0, so it is not encrypted. So we need to encrypt this by going to global config. So config T, then type in service password encryption. Then I will show the running configuration. So as you can see, the password is now encrypted. Next is we provide legal notification. So you need to go back to global configuration and then type in banner MOTD and then hashtag. So enter text message and with a character hashtag. So type in unauthorized, authorized access is not allowed. Then hashtag. Okay. And then for the last configuration, we need to save it to the NVRAM. So all this configuration, the running configuration, it is saved to the RAM. So whenever we power off the switch, so all the running configuration will not be saved. So we need to save it to the NVRAM. So how do we do it? Just type in copy running config startup config. So this means that we are copying the running configuration, the current configuration, to the startup config. So enter destination file. Okay. Next is we configure the switch. So we'll use the same commands. So and type in enable config t. So for the host name of the router, hostname router 1, for example. Then as you can see, the R1 changes to router 1. Then secure user exec mode. So line console 0. Type in the password Cisco. You need to log in, and then secure privilege exec mode. So enable secret class. So we should also secure all passwords. We need to encrypt this password Cisco. So type in service password encryption, and then also need to display the banner message. So unauthorized unauthorized access is not allowed. And then we will save the configuration to NVRAM. So that's it. So for saving the configuration, we need to type in copy running config startup config. So in this video, we will be configuring the DHCP and DNS on the WLAN and LAN. So the DHCP, which stands for Dynamic Host Configuration Protocol. So it is a protocol that automatically assigns an IP address on the device that connects to a network. So in this example, we will be supplying IP addresses to these two devices here, the PC and the laptop. So as you can see, we doesn't have an IP address. So for example, we are requesting for IP address DHCP. DHCP failed. APIPA is being used, so we're not using that APIPA. And then for the laptop, we also don't have IP address. Okay, so how do we do that? So first in the router, I also prepared the commands to set up the DHCP of the router. So first, Cisco plus password Cisco, then enable. We need to go to global configuration, then set the password plus. Okay, then config key. So first, we need the IP DHCP pool deploy. We need to enter this command. So this means that we are saying that the router that will be configuring the DHCP. Okay. So as you can see, the config here, the word config here changes to DHCP-config. Next is the network. So the router 1 is here. we need to set up the network. So type in network, then plus the network address that we need the DHCP address. So in this LAN we need that, and the network address for that is 192.168.11.0. plus we also need to enter the subnet mask. So 255.255.248, and then we should also set up the default router. So the default gateway is the interface 0/1 of the router. So type in default router /router plus the default gateway is 192.168.11.1. Next is we need to define the DNS server. So type in the DNS server, DNS/dash server, and then the IP address of the server. So as I remembered, the IP address of the server is 192.168.10.1, 10.2. Okay. The next thing we do is go back to the privilege exec mode. So we hit exit at global configuration. We need just hit the exit, and then we need to exclude some IP address from being assigned from the DHCP. So type in IP DHCP included -IP address. Then for the IP address range, so we already have an IP address for the router interface, the /0/1 and the PC. So we will exclude the addresses. So type in 192.168.11.1. So this is the default gateway, so we don't want to assign the DHCP there. And then we also need to enter the IP address of PC because we already have the IP address. That 11.2. Okay, that's it. We hit exit. So let's test this. Requesting IP address. So a DHCP request successful for our LAN. So the PC here, we supply the DHCP address of 192.168.11.3 with the subnet mask of /29. Default gateway we also assigned it, and the DNS server that we type in on the router. Next is we will supply the IP address for this laptop. So for the wireless LAN, then we need to configure this router here. Same commands will be used. We need to access the global configuration. So config T. Type in the IP DHCP pool deploy, and then we need to type in the network plus the network address of this WLAN. So 10.1.1.0 plus the subnet mask 255.255.255.248. And then next is the default router. So type in default router plus the default gateway of the router. So G0/0, so 110.1.1.1. So I remembered. Okay, next is we need to define the DNS server. So type in DNS server plus the IP address of the servers. So we all need to type in 192.168.1.2 at 10.2. This is the IP address of our server, the central server, and then we hit exit. Then we also need to exclude some IP addresses, so IP address range. So we need to exclude these addresses: 10.1.1.1 to 10.1.1. I think this is 3. 4. 1, 2, 3, 4. Dot 4. Okay. Sit. I will test the laptop. So DHCP requesting IP address. DHCP request successful. So we also supplied DHCP on wireless LAN. So we have now the IP address for the laptop 10.1.1.5 with the subnet mask of 255.255.255.248. Okay. Next is we need to configure the DNS or the domain name system. Okay. What I mean is, for example, we need to access the website of the server. For example, the server named cisco.com. Okay, we need to access it. So for the web browser, first we need to access its IP address 192.168.10.2. So Cisco packet tracer welcomes. Now when we type in cisco.com to access this server, host name unresolved. So we will work to that. What we'll do is go to the DNS server, the server, then services, then go to DNS. So make sure the DNS service is on. So we'll configure the DNS service. Next is we need to type in the name, the domain name. For example, cisco.com. And then we need to add the server for the address for the server 192.168.10.2, and we need to add this. So we will access the cisco.com from our browser from PC1. So cisco.com, hostname unresolved. Okay, we are not configuring the DNS server, so we use the DNS server 192.168.10.2. This is our DNS server. And for the PC, we need this default gateway. Why it is not configured? And then for the laptop, we also need. Okay. So we will now try to access cisco.com through our browser. So cisco.com. So it works. Cisco packet tracer, welcome to the website of this server. We will also need to test the DNS on our laptop, cisco.com. So it also works. So this part of the video is all about configuring and verifying email services on servers. So first thing we need to do is configure the server for sending SMTP email and receiving POP3 email. So SMTP, which stands for Simple Mail Transfer Protocol, and that protocol is used for sending emails. And then for receiving POP3 email, so POP3 email is, which stands for Post Office Protocol. First thing we need to do is click the server, then services, find email. So make sure the SMTP service and POP3 service is on, both on. So first thing we do is set the domain name. So type in cisco.com, for example, then click set. Next thing we do is create an account for the server. It's for the user setup. So type in, for example, Owen Patrick, and then for the password is Cisco. Then click this plus sign, means add. Then we also need to create another account. So type in markwords. Then for the password is Cisco. Okay. So the step 2 is we need to configure these two end devices. So we will use this PC for LAN and the laptop for WLAN. So we need to configure this to use the email service on the server. So how do we do this? So click on the PC, go on the desktop, and click email. So it's like creating an account. So the user information, type in your name. So for example, Owen Patrick. Next is the email address. So owenpatrick@cisco.com. Next is the server information. So we need to type in the IP address of the server, cisco.com. So 192.168.10.2. So incoming mail server is the same as the outgoing. Then log on information. For the username, Owen Patrick. Then for the password is Cisco. Then save. We need to click receive to verify. You're receiving mail from POP3 server. Receive mail success. So we already configured the email services on the PC in the LAN, local area network. Now we will configure the laptop from the WLAN or the wireless LAN. So it's the same. Click on the laptop. Next, click the desktop and find the email. So we'll also configure this. So we will type in our second account, the credentials for our second account. So type in your name. So for example, Mark Birds. Then for the email address, we need to type in markbirds@cisco.com. Next is the incoming mail server, the server information, the 198.160. The IP address for the server. Then incoming and outgoing is the same. Login information, our username, markbirds. Then for the password is Cisco. Save. We need to click the receive to verify. Then receive mail access. Receiving mail from POP3 server. And then receive mail success. Now we need to test the email service. So we need to send a message from this laptop to this PC. So how do we do that? Click email again, then click compose. So we need to send this to this PC with an email address of Owen Patrick. We need to send this email to the user, the PC. So owenpatrick@cisco.com. Then for the subject is internet cookie. Then hello computer. Hello then we will send it. Okay, now we will check if the email we sent are successfully transmitted to this account. So click the PC, head to desktop and click the email. Now click the receive, and as you can see, we received the email from markbirds@cisco.com. So with the subject computer networking. So click this. As you can see, from markbirds@cisco.com to my email address and subject computer networking. So now we will reply to this email. So reply hi Mark Birds. Now we will send this reply to markbirds@cisco.com. Send this. We will verify if our email from the PC send to the laptop. So email received, and we received the reply from owenpatrick@cisco.com. So this part of the video is all about using the FTP service. Okay, so first thing we need to do is configure the FTP service on server. Second is we need to upload a file to the FTP server. So we'll use this laptop to upload the file to this server. Then next is we need to download a file from the FTP server. So we will use this PC to download the file. So first thing we need to do is configure FTP service on the server. So click the server, then click the service. Make sure find the FTP and make sure that the service for the FTP is on. Next is we need to create a user account. So for example, we type in Owen Patrick. For the password is Cisco. Okay, so this account is for just an anonymous account, so we just need to add the permission, but for reading and this only for a file. So click add. We also need to create a user for administrator. So we will grant the administrator the full permission or full access on the server. So we type in administrator. Then for the password is Cisco. Like I said, we will grant the administrator full access, full permission. Okay, let's add this, and this Cisco account, we need to remove this. Okay. So the next thing we do is upload a file to the FTP server. So click this laptop, and then we need to create a text editor. Then open sample file.txt. But we need to create our own file. So hello. So computer networking. Working is the best. Then we need to save this. The document is modified. Do you want to save this? Save. Enter the file name. Networking. Working.txt. Okay. Next, we need to upload this to the FTP server, and then we will upload this by using the command prompt. Oh, wait. FTP. The DNS is cisco.com. So for the command prompt, type in FTP cisco.com. Trying to connect cisco.com. So we're now connected. We need to enter our server. We need to use the credentials for administrator. So type in administrator. Then for the password is Cisco. Okay, login, passive mode on. So we need to upload a file to the FTP server. So by using put, let's check put networking dot text file transfer in progress. Now the file is successfully transferred to the server. Now we need to verify the transfer of the file by typing dir. So as you can see on the list, we don't have the networking. There, the number 31, networking.txt. Okay, once there, we need to quit. Okay, next thing we do is download the file from the FTP server. So we uploaded the file from the laptop here, and now we will download the file from this PC. Okay, next is text editor file. We don't have the file yet. Command prompt FTP, type in ftp.cisco.com, so we can communicate with the server. Type in our account. So this account has the permission just for read and list. So for the username, type in Mark Birds. Need account for login. No such account. See this, the account TP. Owen Patrick. I'm so sorry. Owen Patrick. So ftpcisco.com. Put the username Owen Patrick, and then password Cisco. Now we need to download the file from the laptop to our PC. So we need to type in get networking dot text. Okay, transfer complete, 33 bytes. But first we need to verify that the account that we created, we don't have the permission to write a file. For example, we need to type input sample file.txt. So this is the file that we saw on the text editor. So request action not taken, permission denied. So now we will verify if we already received the file. Okay, then click quit, then type in there. So as you can see, we now have the networking file, networking.txt file. So we'll text editor open. Now we have the networking text. Computer networking is the best. For the last topic, for the part of our video, we'll be configuring Telnet and SSH. So we use Telnet and SSH to remotely access computers. So for our video, we will be configuring Telnet on the router. So first, what we need to do is Cisco, then enable, go to the configuration mode, global configuration, then class, type in config t. Then first we need to secure the VTY lines. So type in line VTY 015. So 015 are all the interfaces, virtual interfaces. Next is we need to type in our password. So we just type in password Cisco, then log in, then exit. Next is to set our username and password. So type in username admin, then password admin. Next is we need to tell the router to authenticate all incoming virtual terminal sessions. So type in live VTY015, then type in login local. And that's it. That's it. We can now access this router through this PC. So in the command prompt, type in telnet plus the IP address of the interface of our router. So for example, 192.168.11.1. So user another access is not allowed. The user access verification. So for our username, admin, password admin. So we can now enable class. So we can now access the router configuration through our PC. Okay, next is we need to configure the SSH. So now we will heading back to the router. So on the router 1 configuration, we need to type in this. So these codes here or commands here are for configuring SSH on our router. So type in IP domain name cisco.com to the global configuration. Next is crypto key generate RSA. So it is used to generate a key pair which will have a private and public RSA key. So crypto key generate RSA. Okay. Then now we need to type in our username and password like we did on the telnet. Username admin and then password admin. Next is we need to head to line VTY015, access our VTY lines, then type in transport input SSH. So this command means that we limit the router for SSH connections only. So obviously our telnet access, telnet configuration early on that we configure, it was disabled. Next is we need to type in login local and hit exit. Now we can access this router through this PC via SSH. So for the command prompt, we need to type in hit exit. Exit this first. Then type in SSH-L, then our username, which is admin, plus the IP address of the router, the interface of the router, which is 192.168.11.1. So we need to type in our password, which is the admin also. So we can now access the router through SSH. So for the part 3 of our video requirement, we will be simulating our network topology, but first we need to discuss some show commands. So we have here five show commands. First is the ipconfig. So ipconfig is just displays the configurations done in a host computer. Configurations done in a host computer. So later on we will be executing this command in a PC. So for the ARP command displays the contents or list of the devices currently in the ARP cache. So devices in ARP cache. Next show command is the show CDP neighbors. So this show command displays some information of the neighboring device. So for example, in our topology, we have here the router. So the neighboring devices of this router is the switch, at these two switches and another router. So to show the CDP neighbors is information from neighboring devices. We also have the show IP interface brief, and it's displays the information of assigned IP addresses in the interface. For example, on the router, so it displays the IP addresses of gigabit Ethernet 0/0 and then 0/1. So it also displays the status of the interface. So information on interfaces. And then the show running config command is just displays the current configuration. Now we will execute these commands. For the IP config, we will execute this on command prompt. So IP config. So as you can see, it displays the local link local IPv6 address, the IP address, the subnet mask, and then the default gateway. Next is the ARP command. So it also executed in the PC. So we type in ARP-A. No ARP entries found. Okay. So we need to, for example, ping the router 192.168.11.1. So we need to ping the router. Okay. Then ARP-A. So as we executed the command, it displays the internet address of the router, IP address of the interface of the router. Next command is the show CDP neighbors. It displays the information of neighboring device. So we'll execute this on the router. So head to the CLI, Cisco enable plus. So in the privilege exec mode, execute the show CDP neighbors. So it displays the neighboring devices such as switch, the router, then the switch, the S1. And then we also have the show CDP neighbors detail. We just add the keyword detail, and it displays the IP addresses in a port. Let's find it. This one, router, the IP address of a router, the interface. Okay. Next is the show in IP interface brief. So it displays the information on interfaces. Show IP interface brief. So as you can see, we have here the interfaces on a router. We have the gigabit Ethernet 0/0, then 0/1. We also have the serial port. We also have IP address in each interface, and then all of the status is up. Then for the final show command is show running config. So it displays the current configuration on the device. for the simulation mode, we will be examining the functionality of TCP and UDP protocol. So the TCP, which stands for Transmission Control Protocol, and the UDP, which stands for User Datagram Protocol. So the main difference between these two is the TCP is more reliable. Okay? Whew, a deep breath. Okay, let's start with the simulation mode. Just click it here, and then first thing we do is generate a traffic. So generate an HTTP traffic and DNS traffic. So in the simulation mode, I already filtered the protocols. So we need the DNS, the HTTP, the TCP, and the UDP. So we will now generate the HTTP traffic. So first, we need to go to the web browser of the PC and request for the server. Just type in its IP address. So 192.168.10.2. Okay. So as we entered the IP address, a PDU appeared here in the PC. Now, we need to generate a DNS traffic by typing in the command prompt ns lookup. So ns lookup is a command that displays the information of the server. So ns lookup plus the domain name cisco.com. So as we type in our command, a PDU appears here. So we will now simulate it. So this PDU is a type TCP, and then this PDU is a type DNS. So we'll simulate it a little. The access point, the router, and then we will pause this. Now we will examine the details of this PDU. So as we can see, we have here the protocol TCP. Okay, in the TCP we will see the source port, the destination port, the sequence number, the acknowledge number. So the source port is 1029 and the destination port is 80. So it is the port for HTTP. Sequence number is 0. So notice that the source port is 1029 and the destination port is 80. Okay, now we will examine the PDUs of the DNS. As you can see, we have here the UDP protocol, and then inside this UDP is the source port, which comes from 1028, and we also have the destination port. So as you would notice, there have no acknowledge number and the sequence number, because like I said, TCP is more reliable than UDP. So it acknowledges the data that is transmitted. Okay, so let's continue the simulation. Okay, then it will be heading back to their devices, and then right there. Let's pause this. Now we will again examine the PDU, the TCP. So for the TCP, the source port now is now 80. Then the destination port is now 1029. So we have, so sequence number is still 0, but the acknowledge number changes to 1. Okay. And then for the PDU, so the UDP, so the source port now became the 53. The destination port is now 1028. Okay. Now as you would notice, there a PDU appeared, another PDU appeared, and this type is HTTP. And this PDU, it means that it is the beginning of HTTP communication.